Okay, pages 13 and 14, section E. First it says, find the log button and the natural log button on your calculator. The log button is here. The natural log button is here. Some people think that that is IN, but it's actually LN, natural log. So the way you use them is just to say like log of 2 is, and then it gives you a number. And you can see you don't even need to complete the parentheses, although it's probably not a good habit. Okay, so that's how you use it. So, first problem, we're going to do ACE. ACE. So let's do A. Solve for x, giving an exact answer in base 10. When you don't know where you're going with this, just take the log of both sides, because you know that since there's an unknown in the exponent, you want to end up doing a log to figure out what that is. We don't know exactly how to do that yet, so we'll just take the log of both sides and we'll get log of 2 to the x is equal to log 10. Well, log of 2 to the x, we can rewrite that. We could write x log of 2, and these logs are base 10. That's why I wrote log, and we didn't write anything in terms of a subscript base next to it. Log of 10, that's 1, right? Because log of 10 to the first is just 1. Okay? And then so x is equal to 1 divided by log of 2. Okay? So we were able to simplify that into an expression. Now if you want to, you could actually do that in your calculator to find out exactly what it is. You could say 1 divided by log 2. And the answer is 3.32, etc. Okay? And you could even kind of check that. If you plug the x back into the original equation, if you put 2 to the third, it's actually 3.32, but we can't do that in our head. If we do 2 to the third, we get 8, right? And if we do 2 to the fourth, we get 16. So 10 is somewhere between those two, closer to 8 than it is to 16. So it makes sense that the answer is 3.32, right? Okay, now we'll do E. So 3/4 to the x is equal to 1.1, and it's kind of hard to see what we're doing here, but when in doubt for these problems, take the log of both sides. Okay, log of 0.1 is actually log of 10 to the negative 1. Log of 10 to the negative 1 is equal to negative 1. Log of 3/4 to the x is the same thing as x log of 3/4. Now we have x is equal to negative 1 divided by log of 3/4. Okay. And then we do C. 4 to the x is equal to 100. When in doubt, take the log of both sides. So now we have log of 100. Log of 100 is 2, if you remember, because the log of 100 is saying how many zeros are there in 100. There's 2. Log of 4 to the x is the same thing as x log 4. So x is equal to 2 divided by log 4. We might even be able to simplify that because log of 4 is log of 2 squared. Which is equal to 2 log 2, so it's actually like equal to 1 over log 2. Okay, all right, now for 2, we're going to do ACE again. So solve for x, giving an exact answer. E to the what is 10? Okay, now in this case, they're using E. So if we do the natural log of both sides, it's something that's probably going to work out better than doing log base 10. So these cancel out. You get x equals e to the 10. Okay. Let's see. E. And that's the answer you want because it says to give an exact answer, not to put it in the calculator. Once you put it in the calculator, it's going to give you an approximate answer, and they want an exact answer here. E to the 2x is equal to 18. Let's take the log of both sides because we don't know what we're doing And that'll give us 2x is equal to the natural log of 18. So x is equal to the natural log of 18 divided by 2. Okay, and C. 2e to the x is equal to 0.3. Take the natural log of both sides. Actually, before we do that, let's do this first. Divide both sides by 2. Let's try to isolate the e a little bit. That'll give us e to the x is equal to 0.3 divided by 2. 0.3 divided by 2 is 1.5. So e to the x equals 1.5. Now take the natural log of both sides. Now you have x is equal to the natural log of 1.5. That's better. Okay, this one we're going to do all. Consider the equation r is equal to 200 times 2 to the 0.25t. Rearrange the equation to give t in terms of r. Okay, so this is what log is going to enable you to do that we were unable to do without log. Take things in the exponent and make them the subject of the equation. So what we're going to do first is we're going to try to isolate this, so we divide both sides by 200, right? So we get r over 200 is equal to 2 to the 0.25t. Now to get t into the, out of the exponent, we need to take the log of both sides. So let's take the log of this side. And since it's base 2, it doesn't really make any difference which kind of log we take. So we have log of r over 100. No, log of r over 100. So log of r over 200 is equal to 0.25t times the log of 2. Now we have 0.25t. We're going to divide both sides by log of 2, you can see, right, to further isolate that. So now we have, these cancel. So now we have 0.25t equals log of r over 200 divided by log of 2. And then we're going to divide both sides by 0.25, and then we're going to be completely done. Right? So now we have t equals something. Okay? The next says, hence find t when r is equal to 600. So all you need to do there is you need to put 600 in for the r there. Find it when r equals 1425. Same thing, you just put 1425 in there. And you just you divide it by 200, and then you take the log of that quantity, and then you divide it by the log of 2, and then you divide by 0.25. So many steps there, but it's just a calculator usage. For number 4, the first thing that we want to do is we want to start isolating the x. We don't want to take a log yet because we got this, we got this 20 multiplied out front. So we're going to divide both sides by 20. And then now we're going to take the log. Log of m over 20 is equal to log of 5 to the negative 0.02 x. And then we're going to, and then we're going to take the left side, we're going to leave log of m over 20. And then we're going to put negative 0.02x times the log of 5. And then we divide both sides by negative 0.02 times the log of 5. And then on the right side, we cancel those out, we're left with x, and then this is our expression. And then when it says, okay, find x when m is 100, all you need to do is put 100 in there. And then use your calculator to do those multiplications and divisions. And then you put 232 in. Okay? So that's just calculator operation. Now we're going to do ACE. Solve for x giving an exact answer. So um, 4 times 2 to the minus x is equal to 0.12. First thing we can do is we could divide both sides by 4. And then we get 2 to the minus x is equal to 0.12 divided by 4 is 0.03. And then 2 to the, so that would be, you could take the log of 2 to the negative x is equal to the log of 0.03. And then log of 2 to the negative x is the same thing as negative x log of 2 is equal to the log of 0.03, which is you divide both sides by log of 2, log of 2, and then you end up with negative x is equal to the log of 0.03 divided by the log of 2, which is the same thing as, oops, and so you could just take the negative of both sides, right? So you have positive x is equal to negative log of 0.03 log of 2. Sorry about the handwriting here. My handwriting is already bad without using the pen, but it gets even worse. Okay, for this first one, C, the first thing you want to do is divide both sides by 3, or by 32, because you want to eliminate the 32 from the left side. So then you're left with 3 negative 0.25x is equal to, I'm sorry, did I say 32? You're supposed to divide by 32. 4 divided by 32, which, by the way, is 1 over 8. 1 over 8. Now you can take the log of both sides. So you take the log of 3 to the negative 0.25x is equal to 1/8. Oh, log of 1/8. Log of 1/8. So now we can put the exponent out front. And then we have log of 1/8. And then you have x is equal to the log of 1/8 divided by negative 0.25 log of 3. Okay. We don't have room to do e here, do we? Here's some space. So e, 50 times e to the negative 0.03 x is equal to 0.05. Okay, so first thing we do is we want to get the x by itself. So we divide both sides by 50 in order to get e to the negative 0.03x is equal to negative 0.05 divided by 50. That would be the same as negative 0.01 divided by 10, which is the same thing as negative, no, I'm sorry, not negative, 0.001. Okay, and then you take the log of both sides. So then you have, and let's take the natural log because since it's an e, by natural log, it's going to work out better. So then we have natural log and e cancel out. So then you get negative 0.03x is equal to the natural log of 0.001. Then you have x is equal to the natural log of 0.001 divided by negative 0.03. Okay? All right. We're getting close to the end here. We're going to do A, C, E. Okay, solve for x. E to the 2x is equal to 2e to the x. Let's see. What if we took, let's see, we're going to combine the terms with x's in them. So we're going to do e to the 2x. Let's divide both sides by e to the x. And then we end up with that, right? A. And then we get e to the x squared divided by e to the x is equal to 2. And then so we basically have, this cancels out with one of those, so we end up with e to the x equals 2. E to the x equals 2, so what's x? Well, if we take the natural log of both sides, then x is equal to the natural log of 2. Okay? E should bring back memories of the last unit. This is not obvious how to solve this. You need to get all the x's together, and you can't do that just by subtracting both sides. It's kind of a trick. So multiply everything by e to the x. That's the trick. And if you do that, then you're going to get 12 times 1, because e to the positive x times e to the minus x is just equal to e to the 0, which is 1. And this is also multiplied times e to the x, so it's e to the 2x. Now, let's subtract everything over to one side. Now do you see that it is now a kind of like a quadratic equation like we saw in the last chapter? So if we do the Jinsdale substitution, we would say t is equal to e to the x. And if we do that, then this would be t squared minus t minus 12. And then we could say it's t minus 4t plus 3 if we factor. And then we can see that t could be equal 4 or t could be equal to negative 3. And then, let's see. We know that e to the x can never be a negative number. So this solution is not going to work out. So basically we're left with, hey, e to the x is equal to 4. So that means if you take the natural log of both sides, you'll see that x is equal to the natural log of 4. Okay, so this is the only possible solution because this solution does not work. Okay, now we're going to be doing the last one here, which is C. E to the 2x minus 5e to the x plus 6 equals 0. And if you had done C before E like you should have, then probably E wouldn't be so hard to see, because here they introduce you to the function of that e to the x's can be formed into quadratic. So we'll say use the Jinsdale substitution, and t equals e to the x, so that means t squared minus 5t plus 6 is equal to 0. So then you can factor that into t minus 2 times t plus 3. And then, so the solutions, the possible solutions are t equals 2 or t equals negative 3. So then we know that e to the x is equal to 2 or e to the x is equal to negative 3. But we know that e to the exponent can never give a negative value, so that one's not possible. So that leaves us with taking the natural log of both sides. We'll see that x equals the natural log of 2. Okay. All right. Last one. Find algebraically the points of intersection of, and we have 2 to do here. Okay, so the intersection of this and this. So if we want to find where they intersect, well, the y's and the x's are the same. So we set the y's equal to each other, and so then basically we can set, this equal to this because the y is equal to each other. And then we'll subtract everything to one side. And then we have this, which we can do the Jinsdale substitution. At least, now they're always giving us e to the x, so the Jinsdale substitution is always the same. So then that's equal to t minus 3, t plus 2 equals 0. So that means the possible solutions are t equals 3 or t equals negative 2. But we know that e to the x can never be equal to negative 2. So we're just going to say e to the x equals 3, so that means x is equal to log of 3. Okay, now we're going to do C. We're going to find, by the way, and that's the x point is log 3. Now, when you have a point of intersection, you need to know the y also. So you can take either one of these y equations to figure out what y would be, and it's easier to do this one because it's like so small. E to the natural log of 3 is just 3. So the point is natural log of 3 for the x-coordinate and 3 for the y-coordinate. Now let's do C. So we're going to intersect 3 minus e to the x with 5e to the negative x plus minus 3. So we are going to combine the constants. So that would be 3 plus 3 is 6. Minus e to the x minus 5e to the negative x is equal to 0. Then we're going to multiply everything by e to the x. 6e to the x minus e to the 2x minus 5 e to the 0, because e to the positive x times e to the negative x is e to the 0. E to the 0 happens to be 1, so that's what we have now. So now we have e to the 2x negative plus 6e to the x minus 5 equals 0. And then to make it easier, let's just multiply both sides by -1. Okay, now it's easier, a little bit easier to factor. Using the Jinsale method, we substitute in e to the x for t. And then we get t plus t minus 1 and t minus 5. So the solutions are t equals 1, t equals 5. Those are both possible solutions because e to the x can be 1, e to the x can be 5. What makes e to the x 1? X equals 0. And what makes e to the x 5? Natural log of 5. So there's 2 points. There's one that's 0 comma something, and there's one that's natural log of 5 comma something. How do we find the y-coordinate? The y-coordinate, we just use the original equation, which is like y equals, this one looks easier to use, doesn't it? So y is equal to 7 minus e to the x. So in the case of this one, x is 0, so it's 7 minus e to the 0, so that's just 7 minus e. And then for this one, natural log of 5, e to the natural log of 5 is 5, 7 minus 5 is 2. Okay? So we're done.